on a science fair project, and it was also similarly about multiple sclerosis and also like another thing called neurotrophic factors. And after that project, I also had a coffee chat with the multiple sclerosis research chair of Canada. And so he was also specialized in neuroimaging, which inspired me to work on kind of the MRI part of this project and also further my research in general.
All right. Thanks. Continue with the PPT.
Okay, cool. All right. So this project is the multiple sclerosis analyzer. The problem statement. So as I just previously mentioned, the diagnosis of multiple sclerosis is obviously very complex and multifaceted. It includes various techniques such as magnetic resonance imaging, MRI, scans, evoked potentials, and also clinical assessments. And a lot of clinicians struggle with it because there's so many aspects to take into account. And so multiple sclerosis symptoms are often also heterogeneous, meaning that it is of different causes, severity, and also pathophysiology, which is why it's also contributing to this complexity. So early and accurate diagnosis and risk recognition is crucial to slowing down disease progression, thus the need for a comprehensive and trained model of MS analyzer.
Okay.
And which is why we created the multiple sclerosis analyzer. Later on, I could also show you guys the website and interface. But first of all, there's two parts, and our project kind of targets the complexity of it, of multiple sclerosis. I could also talk more about multiple sclerosis first. MS is a neurological disorder leading to neurons losing their insulation coats, or as you can see, it's called the myelin. And so it is a debilitating disease, and it's often disabling also, and it leads to decline in cognitive processes. So as previously mentioned, early intervention is key, especially when there's no definitive care for MS at this moment. So our project is separated into two parts. First of all, it's, as you can see on the left, the MS magnetic resonance imaging scan analyzer, where you upload a brain scan to receive real-time detection of MS brain lesions. And then second of all, it's a multiple sclerosis predictor, where patients insert their personal information to obtain further analysis on their risk of MS or their MS status. And it's also applicable to clinicians as well.
Okay, understood. Just one question, just out of curiosity, condition, does it is there a specific age group that it affects towards?
A specific case group?
Age group. Age.
Oh, age group that like mainly multiple sclerosis affects? Yes, usually it is early adult. So early adulthood and like about 30 is the most common onset age.
Understood. Let's continue.
Okay. So obviously the need for an MS analyzer is very apparent. It is a neurodegenerative disorder resulting in permanent damage and also just an effect in quality of life for patients. It is estimated that 2.8 million people are affected by multiple sclerosis across the globe.
Understood.
All right, more on to the project itself. It has two pieces. So the first part is where the patient answers 15 questions about themselves to predict some MS status. And then the other part is using generative AI. And basically, it's a model that analyzes MRI scans. First, we'll describe the question-based part. This part is fueled by a data set of a few hundred samples, and all the intelligence of the machine is governed by the training data alone and not anything else.
Okay.
All right. And so we used a classification algorithm. It is a machine learning task where the computer has to predict which category a sample should fall into based on some information about it. And specifically, our problem of predicting whether a patient is positive or negative for MS is a binary classification task with two possible categories. And so the goal of the machine is to synthesize the training data to make predictions about incoming data. For example, a sample could state that a patient is male, has 12 years of schooling, is 44 years old, and is able to predict, etc., and is positive for MS. Then, through machine learning algorithms, the computer is able to predict whether the patient is positive for MS in a way that reflects the training data. And out of the few classical algorithms, we chose to use random forests.
Okay.
More about random forests. First of all, decision trees are the building blocks of our chosen algorithm, which reflects the way we think in our brains. And, well, ironic, it is also about analyzing the brain. And a general example of this decision tree, not in the context of ML, is classifying animals. So, for example, a decision tree might ask yes or no questions, like is it taller than 1 meter, or does it have 4 limbs? And then after each question, it plans a specific path to guide the user down, answering questions based on previous questions. And so this is best modeled by a tree structure because the questions are adaptive and doesn't follow a very specific path. So in the context of ML, though, the decision trees are constructed to follow training data from the table, like the training table. And then many trees are constructed based on different parts of the data table to pick up on different informations. And then a tree might build on the symptom and gender data of patients 48 to 61, let's say. And then to predict the incoming data, the trees each run the sample and then feed it through their series of decisions. And then the trees would kind of like vote diplomatically, whether like each category is voted most for the final output, like whether it is positive or negative.
Okay, nicely explained.
Okay. And then the second part of our project, which is the scanned part, is using large language model, LLM. Essentially, it's a mainstream AI programs like ChatGPT. And in our case, we use Gemini Pro, and we're lucky to be able to access Gemini Pro. And these models are trained on huge amounts of data, meaning that they can understand most sensible prompts and give accurate answers. So although they're simple to use, they have been used carefully. As developers, we provided a detailed prompt, otherwise we risk receiving an output that is not relevant for the patient's output. And they also require libraries, correct syntax, and an API key to be used in Python and to be developed and to be deployed.
Understood.
Okay, more onto the deployment itself. After the code has been created in Python, it's not done yet. So the code first has to be inside VS Code and then to be properly compatible with other deployment tools. And then we use Streamlit to deploy our project. And Streamlit is ideal for our scale because we care about convenience and simplicity more than network scalability for large amounts of users, obviously. And finally, GitHub is also used to store the files in another server so that developers don't have to use our own computer's processing power to keep the project running for everyone else.
Understood. Okay.
And more onto application and future scope, which is how we use our project. First of all, for applications, we hope this project would support clinical decisions, and we hope that this project could also provide some personal treatment and diagnosis for all patients, but it would be mainly used for educational purpose for now. Obviously, because this is not a very well-developed project because of the tight timeline, we also hope to expand our data set and have more patient-friendly user experience and also explain maybe what each question means to the patient. And we also hope to predict treatment response later on in this project.
Okay.
So that's a bit about what we hope to do, maybe if we have time later on. And that's it for the presentation.
A really nice presentation, by the way. It was nicely structured. A good one. Okay. Do you have a demonstration of the project? We'll get started with that then.
Okay. I will have to pull up the link from somewhere else.
No issues. Take your time. Meanwhile, I had a word with a mentor a while ago, and he complimented you on how you clubbed your interests, neuroscience and CS together. It was nice to hear that. He was complimenting on you on how disciplined you were on during the lectures, and other than that, just having creative ideas towards your project. So yeah, that is something that I wanted to compliment on the mentor.
Thank you so much. I wasn't able to make things because of the rescheduled time and how like after rescheduling it, it kind of conflicted with other things. So
Understood.
yeah, that kind of in like a harder and tighter timeline throughout the project too. So yeah, my teammate has really played a crucial role in that.
Okay, nice to hear that. What would you say about the mentor? How,
I'd say mentor is he is really helpful. And personally, as someone who doesn't really have a lot of program experience, I feel like the way he explains it is very beginner friendly, and that he takes into account whether I would understand things or not, and like he knows to what extent he should explain it. So
okay,
I
that's
really like that. Yeah.
um, you have your link ready? It's fine.
Yes.
It's
Okay.
fine. Take your time. Fine, take your time.
Okay. All right. So here is our MRI scan analyzer. So you just basically drag and drop a file, and then if you want to, you could also add any other context. But if you'd like to be very specific and have like, like have questions guiding you throughout it, then this would be the thing you'd use, which is the MS predictor. And
Okay.
so you insert basically basic information about your gender, age, and a lot of things. And as you can see, there's also very complicated clinical assessments that
Yes,
are included, which is why I previously mentioned it would be really helpful if we further develop it by making it user friendly for the patients as well.
understood. How do you plan on doing that? Any insights on that if you can?
Mainly it would just be maybe providing instructions on how to do these clinical assessments or explaining what these assessments are, and then make a step-by-step process, and hopefully the patients would be able to follow through.
Okay, understood. Anyways, so can we get it working right now? Can we have a demonstration of it?
Yeah,
Or okay,
absolutely.
it's fine if you
So,
have pre-entered parameters in it, and we just get the results. So even that is fine.
okay, let's say I were to predict it right now, I'd be positive.
Okay, all right, understood.
And here's another part of it. Let me just find another multiple sclerosis image. Okay, so I downloaded an image, and I'm going to drag it down here.
Okay,
All right, and it's going to take a bit of time.
okay, sure. Meanwhile, can you tell me how it was working with your teammates? What was the role that you were assigned, or the major part that you focused upon while building the project?
Mainly, I think our teamwork and like division of labor was really clear and distinct because my teammate is very knowledgeable in with regarding AI and also coding. So he was the ones that shared his expertise regarding that field, while I provided more knowledge about neuroscience and
Mhm.
like yeah, the ideation and the concept of this project.
Understood. Very nicely regarded. Okay. Is it ready? Okay.
Yeah. All right. So as we see, we had a disclaimer here, and we can see the signs of demyelination, which is like the loss of the insulation coat of the neuron, and also lesions, which is the injuries, basically. So we can see that, yeah, there are several lesions, which is correct. And it also told you the name of it, which is Dawson's fingers. And
Okay.
then problems of diagnosis and recommendations for follow-up. And yeah, any urgent concerns.
Okay, understood. Oh, that was nice. A really nice and simple UI as well. So yeah, a great project. Okay, you can stop sharing the screen right now. All right.